Very quickly, we'll be solving the following and we'll be finding the unknown angles. Now, we'll be using the theorems I stated earlier in the previous class, and also some basic theorems that we know about already, which are some of angles in a triangle, some of angles on a straight line, some of angles at a point, vertically opposite angles, and if there's any other theorem like that. Very quickly, moving to this one. In our previous class, which is the one where I stated the theorems, I gave a theorem that says that what the angle with which an arc subtends at the center of the circle is twice the angle it subtends at any other point. Now, if you apply that theorem to this one, you discover that what x is actually what 35 times 2, and x is equal to 70. Apply that same theorem because this is the arc here now, with which this angle is subtended here, and it is this same arc with which this one was subtended, right? And it's also this same arc that this one was also subtended at the circumference of this circle. It means that what y is what x divided by 2, because this is twice any other angle with which it subtends at any other point on the circumference of your circle. And so your y will be actually x divided by 2, which is 70 divided by 2, which would give us 35 degrees. Okay, moving to the second question. Now this looks technical, but it's actually very simple. It's actually very simple. There might be some parts where you need to find, but you might have to find some parts that are not indicated first before you get the indicated parts. So it doesn't mean that you have to look for a formula that must give you the straight answers to these three particular values. You might need to find the value of probably this one here, or this one, to be able to successfully get the value of the indicated letters or angles. Are you getting me now? Okay. Looking at this one, there's a theorem that says that what opposite angles in a cyclic quadrilateral are supplementary. Now, the first trick behind this question is that they put all these things so that you fix your gaze on all these things rather than trying to remove certain parts. Sometimes you might have to remove a triangle out of the whole picture to get a theorem right. Sometimes you have to remove this one out or take a little part like this out. But in this scenario now, look at it from a whole perspective. Discover that this thing here is a what? Is a cyclic quadrilateral. And this angle here is opposite to this angle. So it means that this particular angle will become what? 180 minus 100. How is it 180 minus 100? This plus this is equal to 180. Remember, they are supplementary, right? So it means to get this, you subtract it from what? Subtract this from what? 180. So 180 minus 100 would actually give us what? 80. 180 minus 100 would actually give us what? 80 degrees. Now let's put this 80 degrees here. How do we get M, N, and O? How does this relate to this? Remember this theorem that we just applied here now? The angle with which it subtends at the center, right, is equal to what? Twice the angle it subtends at any other point. Now look at this. Take a look at this shape now. You will discover that N is actually 80 times 2, which is 160 degrees. Now there's a connection between N and O, right? How do we find O? N plus O is equal to 360. Sum of angles at a what? Point. Sum of angles at a point. So it means N being 160 now, you subtract 160 from what? 360, which will give us what? 200 degrees. Now finally, how do we find M? How do we find M? Take this part out. Now remember, this means what? That this is a right angle, right? It means this other side is also a what? Right angle. So you can take this out and draw it like this. we will have something like this. Here is 90 degrees, here is 80 degrees. Obviously, we apply our theorem that says that what the sum of angles in a triangle is 180. So we have m here, right? You have remove this out. You have m plus 90 plus 80. We give us what? 180. Now m plus what? 170. We give us 180. M is what? 180 minus 170. M is equals to 10 degrees. And this is how we find the value of the following angles. Take a good look at it. Moving very quickly to the next set of questions. How do we solve these ones? Now, we are still to find the unknown angles, right? Okay. Now, starting from this first one, like I said, sometimes you have to look at the parts, sometimes you look at it from a whole angle, from a whole perspective. Now, look at it from this perspective. Take this triangle out. First of all, you would have something looking like this. Right? This side is what? 21 degrees, right? But you see this sign here. And if you are familiar with geometry, you will know this means what? That this is an isosceles triangle. And there's a theorem that states that what? The base angles of an isosceles triangle are equal. It means here and here are what? Equal. Also, there's also another theorem that says that what? The sum of angles in a triangle is 180. It means 21 plus 21 plus this angle here is equal to what? 180. Now, 21 plus 21 is what? 42. To get this part, you subtract it from what? 180, right? So you have 180 minus 42. And that will give us 138 degrees. Now this is 138 degrees. This is 138 degrees. Take notes. Look at this from the whole perspective now. You see that these four lines, 1, 2, 3, 4, form a cyclic quadrilateral. And S and 138 degrees are what? Are opposite angles to each other. It means they are supplementary. S plus 138 degrees is equals to 180. S is what? 180 minus 138. S is equals to 42 degrees. Moving very quickly to this particular question. Now, like I said before, you might apply some other knowledge you know in geometry before, and you might have to look at it from a whole perspective, or take some part away so you can see some things clearer, so you can know which theorem to apply. Now, looking at this one, to get O, T, and U, you might have to get this angle first. And to get this angle, you use sum of angles on a straight line, which is what? 180. So we have to subtract this from what? 180, and this will give us what? 60 here. So you have 60 degrees here. Remember the theorem that states that what? The angle subtended, between an arc is subtended, is twice the angle that same arc is subtended on any other point on the circumference. It means what? O here is actually what? 2 times 60, which is 120. So O is 120 degrees. Now there's a relationship between O and T. And what is that relationship? Sum of angles at a point. Sum of angles at a point. Sum of angles at a point is 360. So you subtract this from 360 to give us T. Our T will become what? 360 minus 120, which is 240 degrees. Now, finding U, you might want to take this away, but it will not help you like that. You have to look at it inside the circle, because there's a theorem that says that what? Angles in the same segment are what? Equal. So it means this one and this one are actually equal. So you have sum of angles in a triangle to be what? 180, right? And you already have this one to be 120. So you have 120 plus 2u is equals to what? 120 plus 2u is equals to 180 degrees. Okay, now It means your 2u will be equals to 180 minus 120, which is what? 60 degrees, and u will be equals to what? 30 degrees. So we've come to the end of this particular class. Do well to subscribe and share with everyone that you know would benefit from this class. Have a nice day.